Damn, son, where'd you find this?
We'll start this lesson off by looking at integer exponents. So if we have a to the power of something, n, basically we should know that that means it's n, a times n times. So if we have 3 cubed, it'd be 3 times 3 times 3, which equals 27. Let's consider how parentheses affect exponents. So if we have parentheses minus 2 to the power of 4, what we're doing is we're multiplying minus 2 4 times, which will give us positive 16. But if we just have minus 2 to the power of 4, that's going to be a negative, always. If it's an even number as an exponent, then it's going to be a positive number. If it's a odd number, then it's going to be a negative number. So any number with a exponent of 0 equals 1. So that should be clear. 970 with an exponent of 0 equals 1. 701 with an exponent of 0 equals 1. If there's a negative exponent, you put the number and the exponent at the bottom, changing the sign of the exponent to a positive. So 5 to the power of negative 2 equals 1 over 5 to the power of 2 equals 1 over 25. And if it's a negative number with a negative exponent, the number itself would be negative still, and the exponent would be positive. So here I'll just list off some rules that should be followed in any algebra or calculus problem. So to the left, I'm listing off the rules that we'll be using, and to the right of that is an example of how it can be applied. Later in the video, I'll also show a couple examples where all of these rules will be applied. If you feel comfortable with these rules, feel free to skip forward to the questions.
Fuck with your boys.
Damn, son, where'd you find this?
Oh, pull it up, Jamie.
So for this example, we're basically just going to apply everything to the inside of the parentheses. Don't forget, if there's parentheses and exponents on the inside, you multiply those. And then the x to the minus 12 can be turned into sort of a fraction. And from there, we just multiply everything outside of the parentheses with the 1 over x to the power of 12. And we're left with this solution. So for this next example, we have negative 10 times z to the power of 4 times y to the power of negative 4 raised to the power of 2. And then that is going to be multiplied by z to the power of 3 times y raised to the power of negative 5. First, we're going to actually evaluate everything inside of each parentheses individually. Then once we've evaluated that, we will evaluate the two solutions together. This is a typical sort of question you'll see in calculus.
Wow, it's very nice.
Alright, so with this example, we have n to the power of negative 2 times m divided by 7 times m to the power of minus 4 times n to the power of negative 3, which what's going to happen is all the letters with a negative exponent are going to switch sides, and the letters with a positive exponent are going to stay where they are. And then from there, we just multiply and cancel out. So this example, we have 5x to the power of negative 1 times y to the power of minus 4 divided by parentheses 3y to the power of 5 with an exponent negative 2 times x to the power of 9. Now, yes, we're going to do the exact same thing as the last question. The negative exponents will switch sides. The negative exponents at the top will go to the bottom, negative exponents at the bottom will go to the top. Even the 3y to the power of 5, yes, that goes to the top because it has the negative 2 exponent. And then from there, just apply the basic principles. So this question is z to the power of negative 5 divided by z to the power of minus 2 times x to the power of minus 1 with a positive exponent 6 outside of the parentheses. So the first thing we're going to do here is make the negative exponents switch sides from top to bottom, and then we're simply just going to cancel out the z variables. And then once we've dealt with everything inside of the parentheses, then we'll apply the exponent 6 to everything inside of the parentheses. And the next question is going to be 24a to the power of 3 times b to the power of negative 8 divided by 6a to the power of negative 5 times b with the parentheses, and outside the parentheses is negative 2. What we're going to do here, first make the negative exponents switch sides from top to bottom. Then we divide the 24 by 6. And because we have a negative 2 exponent, to make that a positive, what you're going to do is flip everything inside of the parentheses upside down. And then from that point, just apply the positive 2 to everything inside of the parentheses.
Boom, perfect timing.